And today's Fireside Chat is with Ronald van Loon. And I'll talk more about who he is and what he does. Pretty exciting to have him here. But we're going to talk about everything that is interesting to data scientists about data lakes and why they are the future and what's important about them. I'm Anand myself, Anand Narayanan. I'm the Chief Product Officer at Simplilearn, and I manage the roadmap, the vision, and where we are headed at the company. Very excited about the topic today, so let's get started with some certain little housekeeping things. If you haven't ever joined us here at a Fireside Chat, just remember that you can ask us questions at any point. We have folks actually monitoring the questions and answers section. That tab is to the right, by the way. Just make sure you find that. Obviously, we can't answer every single question that comes in. But as they come in, what we'll do is we will pick the most commonly asked questions and make sure those are captured for sure. The way we are going to format this is about 30-40 minutes of what we want to hear from Ronald van Loon, and then another 20 minutes of Q&A session. All right? Now, also, I know that we have folks joining us on live chat on Twitter. You can just follow us there by tagging @Simplilearn in your tweets, and we'll get those tweets as well. We also know that YouTube is a big part of what we're doing today, so welcome folks who are here from YouTube. If you are wanting to find us on YouTube, just go search for Simplilearn, and you should be able to find us very quickly. If you find our channel, you can find us as well. All right, so let's just jump right into the topic, and let's actually introduce Ronald today. Ronald is a good friend of mine. He's also the category advisor for Simplilearn for big data, and more importantly, he's one of the top people in the industry when it comes to big data, as ranked by Analytica. He's the author of a number of publications on big data, data science, and he actually is a part of big websites that talk about data all the time, Dataflog, Data Science Central, The Guardian, and this story can go on and on. But Ronald, a really warm welcome to you. Thank you for joining us today, and really looking forward to this discussion with you.
Thank you, Anand, and really a pleasure for being here and having this opportunity to speak for half an hour or an hour.
Wonderful, wonderful. Let's jump right in. Ronald, I think, there are lots of questions, but let's start actually with data lakes, because a lot of people may not even know exactly what it is. So let's start with a simple thing, which is, what is a data lake? Why should anybody really care about them? I mean, it's a fancy word, but should I really care about what they do? And why would anybody use something like a data lake? Tell us more.
Yeah, so lake is, I think it's a hot topic. It's already a hot topic for quite a while. And the question, of course, is what you ask as well is, why is this? And there's a lot of untapped information stored within all different kinds of data repositories. And if you have a data lake as a central repository where businesses store any kind of data in any form, and whether it's structured, whether it's unstructured data, whether it's modeled or semi-modeled, you want to have the data to get value out of this data. So that's I think the first part. And if you look to some analysts, and one of the analysts that wrote about this is Aberdeen, they had a report and they were investigating, okay, what's the real result? What's the business result for companies that utilize and implement the data lake well? These companies, they are outperforming other companies with 9% revenue growth. So from a business perspective, I think a data lake is very, very valuable as well. But of course, there's more. So organizations really need to size all the opportunities to create value from data lakes and to utilize different approaches to analytics in order to really accelerate decision-making capabilities. I think that's the core. And this might include things like data analytics and visualization, but also automated intelligent technologies. And then you can think about machine learning and AI. So back to your main question. So what are data lakes? If you picture a data lake as some kind of container for massive quantities of data of all varieties, and there's no need to have to alter any of the data before you store it. And I think that's an important difference with structured databases as well. And basically, the data is stored just in the way it is, and whatever the form. So data lakes, they store relational data from business applications, from non-relational data sources, from IoT devices, from social media, from mobile apps, all different kinds of sources. And this is very valuable data now to improve in the end the customer experience and to increase the revenue, what was showed by Aberdeen. So data structures, they are stored in a way that is very, very structured. And this is very valuable data now to improve in the end the customer experience and to increase the revenue, what was showed by Aberdeen. So data structures, they are stored in a way that is very, very structured. And this is very valuable data now to improve in the end the customer experience and to increase the revenue, what was showed by Aberdeen. So aren't characterized when the data is gathered. And so businesses can store all kinds of diverse data without needing to know what types of question you might require to answer on a later date. And this is also very important. So you can easier move on, although I think it's still very important to define all these types of questions, but you can never define all questions up front, as data has a lot of hidden value which you have to discover. So data might be in a raw format, or it might be modeled, or it might be structured. But typically, this type of diverse data, this requires handling from all different kinds of data scientists and data developers, rather than from business analysts who work more and more, of course, with structured data. And these types of data are internal data, external data, IoT data, unstructured, arriving from many different sources, and they are growing at really an astonishing rate. We see every month new type of sources popping up, and especially with all these IoT developments. And they need to be usable through all different types of work process and all different kinds of use cases. So data lakes are repositories that have the potential to be operationalized and offer really significant value for businesses if you find the way to process and manage it well, which can be sometimes still quite a challenge, I think. And data lakes are used by the data architects who design and deploy the business data frameworks, and they're also used by data scientists and app developers who use statistical analysis to solve problems and to optimize business performance. And they are also used by business and by data analysts to provide the business insights and by analyzing reports on a particular data set. So, Anand, does this answer a little bit your question about the data lake?
It does, and actually it sounds very much like the one ring that rules all of the data. Sounds like it can be relational, non-relational, very, very interesting. Yeah. But you go ahead.
Yeah, there's still challenges, but probably you have some questions for me about that as well later on.
Right, we'll have some questions there. Yeah, one thing that, I can tell you that having been around in the industry for a little bit, I'm not too old, but I'll bring that up, that I have seen the word data warehouse, which is quite a common term, has been around for a long time, right? And when you talk about data lake, it sounds so familiar to me, like the term data warehouse I've heard quite a few times before, right? So the question is, I guess, how do we compare these two? And are data warehouses still, do they coexist, or are data lakes taking over? What is going on there?
Yeah, so maybe look to the comparison. If you look, many organizations utilize data warehouses and data lakes because they provide solutions for different needs. So that already indicates from are they replaceable, yes or no, and the answer is partly. So let's start with a data warehouse. A data warehouse is used often at enterprise level, and it can store all kinds of data from operational databases, from business applications, and from other forms of relational data, and is a centralized form of data storage. So data warehouses are capable of storing large quantities, but mainly structured data in a very well organized manner, and they can, and then businesses, because they're very organized, businesses can extract and alter and input the information into their system, and they can be used as needed. So what you see is that the data quality in the data warehouse is much higher, and it's much more reliable from a data warehouse because it has already been structured and has been structured, curated, and it's ready for business analysis to use for all different kinds of applications. So companies utilize the data in data warehouses for all kinds of analytics, and the data has to be properly formatted, and it's ready then available for these applications. What you see is that data warehouses have been processing with the nature of technological and all the industrial advances that we've seen last years, and they're accommodating cloud storage capabilities and real-time analysis capabilities as well. They also allow businesses to keep all the historical data, because data warehouses are capable of storing for the data basically for significant periods, but it's also focused on data that's long-term valuable, months, years, all personal related data. So data warehouses are very valuable for business for a number of reasons, and partly because of the fast and simplified means to access the data, and which can drive real quick and more accurate decision making. And companies are used to this for 20, 30 years right now. So data warehouses, on the other hand, aren't useful unless the data that's stored is very well managed and that it can be applied towards creating all different kinds of opportunities. Now, if we look to data lakes, they're different from the data warehouses, and mainly because of the variety of the different types of formats it can house compared to all kinds of structure and organized nature of the data warehouse. So data lakes are relatively cost efficient because of the unstructured nature of the data, and because of this is an inexpensive format, and businesses are able to manage this to house the data lakes for, let's say, for a longer time for future use. And the data can be extracted at any time and formatted depending on the purpose. Now, if you look to the comparison, maybe let's use an analogy to describe a data lake. Think of a data lake like a swamp. It's called a lake, a swamp. It's some kind of untouched by mankind, a swamp, and left alone because all of the hidden animals and plants are living inside in the swamp. And even though they are a mess of plants, animals, bacteria, nutrients, they are filled with all sorts of things that help the larger ecosystem around them. And I think that's something that you can compare with a data lake as well. They collect these materials from all different kinds of sources in the swamp, from rainfall or from other lakes or rivers and all different kinds of streams, and sometimes even from salt water from the ocean. So without this biological ecosystem within the swamp, the area surrounding them would really falter and collapse because all of these ingredients serve the larger picture of health for this environment. So it is with a data lake in a business environment as well. All of the unformed and raw data from all kinds of sources helps the larger infrastructure of a business and promotes the strategic development and strategic decision making and the real-time decision making. So a data warehouse, on the other hand, is much more like a reservoir of filtered water, where, coming from a water treatment center, and as it's filtered and altered and adjusted, it's really safe to drink, safe to use, basically. And that's how you can compare, I think, as well with the data warehouse. So it isn't useless to use it unless you already treat it. So if you don't have properly treated your data in your data warehouse, you cannot use it. And I think that's the same with drinking water. You need to properly treat it before you can drink it. So I hope this gives a better idea between the difference, Anand, between the difference of a data lake and a data warehouse.
You know, I think the analogy really helped. I think it makes a lot of sense. So basically, you have pre-treated data that is used for specific purposes versus very unstructured and almost random in some sense, random sourced data that you can use for whatever reason, and more cost efficient is kind of the takeaway that I take here as well. So interesting, very good analogy with the whole water treatment thing. But let's talk about something slightly more related and a little bit deeper in this, right? You said organizations need data lakes. This also is relevant to a lot of folks in the forum here, right? Where they're trying to figure out, how does data lake work with my career? How would somebody use it in my company, right? So the question really is, how does a data lake fit into a business ecosystem or an organization? How are these being used? What are the use cases that you see? More about that a little bit.
Yeah, so data lakes are important in the ecosystem, and maybe refer to another report, which is also from the Aberdeen group, that shows the average businesses that witness a volume increase in the data growth for more than 50% average per year on year. So the growth of the amount and volume and variety of data is substantial, and they manage on average 33 different unique data sources. So you can imagine if this is growing by 50% per year, 33 sources, that's substantial. So with a growth like this, businesses are often struggle to manage their internal capabilities. given that they're already depending on this data. So the struggle to access and to use and understand all of the data is why they're turning to data lakes, as they cannot handle this type of data and this volume and this variety in data warehouses anymore. And the data lake is the way to implement as well and to change for companies to change their culture, to create a data-driven culture. And this allows them to create all different kinds of analytics processes, new type of analytics processes as well. So data, I hear myself double now. Data lakes are an important way for businesses to manage all this big data. So the volume, the variety, and the veracity of this data at high speed. And the data lakes, they can help businesses to enrich this massive data sets and make this correlation between this data sets that are spread across all the different various sources which are in the company, like this 33 that Aberdeen is referring to. So integrated tools like, for example, Hadoop are used in these types of large environments and can help businesses obtain value from their raw data in a way that it integrates with other data warehouses. So there are risks of data lakes as well to become unmanageable if businesses don't ensure that it's stored in a useful and in a relevant manner, what we see basically quite often. And this is why the right tools need to be deployed to help organizations manage their data lakes. And I think we discuss this later on in the webcast as well. So data lakes enable businesses to utilize and to analyze data that wasn't readily accessed before. And you can think about social media content or customer service call information, which now can be analyzed in real time. So the potential for data lakes can be extremely valuable for businesses, and this is why it's a hot industry topic already for a longer period. So data lakes can help explore all kinds of possibilities of new and varied data sources and help them to determine, on one hand, all the legacy infrastructures and become more efficient by transferring all the capacity to agile and automated digital infrastructures. So what we see is that organizations should look to integrating data lakes. So it can help them utilize more complex and analytical techniques, and they can make it more accessible and retrieve and improve the speed for more productive and a simple operation. So if we look to data lakes, they're helping companies as well taking the benefits of big data through all kinds of facility and scalability solutions. So data lakes offer a lot of flexibility when they transfer large quantities of data from the data warehouse so that advanced analytics can be conducted on this data. Also, data authenticity can be preserved because data lakes enable businesses to store and to analyze all of their data in all the diverse formats. And businesses can develop the applications they need because they can access all of their different data fast in trusted views. And the data, let's say the application development is very important to become agile and to improve the customer experience. So I think the conclusion is data lakes are the foundation and the driver for improved and efficient business performance and a means for organizations to get more valuable from all the diverse amount of data which is growing tremendously speed right now. So I think this gives a little bit insight why data lakes are important for business.
Yeah, Ronald, but as you speak through this, the thought that goes through my mind is 33 sources on average, a bunch of random formatted data that's coming together, formatted and unformatted, unstructured, structured data coming together. This sounds like a nightmare. So what are some of the challenges organizations run into with data lakes? What are the challenges here?
It can be a nightmare. So quite some companies maybe even fail in managing it. So data lakes often bring up complex questions about the size and the quantity and the diversity of the data sets. And what we see that also they have challenges with the current capabilities in data management processing. So an organization's ability to derive value from the data lake is really dependent on a lot of factors. It's not, let's say, here you have the framework and the template and make it successful. So examples are, what type of development tools and processes and methodologies are you currently being used? Are they traditional? What's the legacy? Or are they new? Another example is the analytics tools that you use, which play an important role because they need to be refined to the process for the different complex types of data. Another aspect is the workload manageability is an important factor. So also the amount of data users that's needed within the business environment, and to this end as well, how fast the data needs to be accessed. So is it real time, or can it be in batches, and for what type of application is it used for? So if the data is compromised or it's damaged, the data lake is definitely not valuable. And this is where it's hard, because in the end, yeah, garbage in is garbage out. So the data, if the data isn't really integrated or properly modified, you can have quite some challenges. So the analysis process will then take longer. You need to do a lot more data preparation than if you compare, let's say, using it what you're used to in a data warehouse. So organizations need to be aware that many forms of cleansing and enrichment and standardization might compromise the data in the data lake and cause some information in this repository to lose its value and its usability. That's what we see quite often. So businesses need to treat the data in a data lake as though the data could have high potential for providing valuable insight. But on the other hand, we have this volume as well, and everybody keeps on storing everything because they think, oh, it can be valuable in the future. And because it's uncertain as to what exactly the data may contain and how it can be valuable, it shouldn't be organized in a simplified way with like objects, because potentially useful and valuable information data may be thrown out or may be lost. So another challenge is that data lakes can become polluted. And when businesses try to utilize too many different tools on the data lake or add the sources with polluted data already, which can be a challenge. What this does create is also tons of data that don't have proper structure, or they don't have a proper quality control process, or not a proper metadata process, which leads to becoming really time-consuming and hard to find the right type of data. And that alone, if you want to use it, it's becoming a nightmare, because either you cannot find it, and on the other hand, it's polluted. So data lakes can also become really bottlenecked, because some of the companies are trying to use data lakes as some kind of form of data warehousing technology instead of a separate type of data storage. So when this happens, the data science team still can derive results, but it's hard to scale, and it's going to be very slow. So companies also need to be careful of the risk which is inherent to data lakes surrounding sensitive and personally identifiable data. So you can store everything, but the question is, are you allowed to? Do you have consent for it? How do you managing this? So organizations have to maintain data protection standards and take steps really to ensure that this type of confidentiality data is not available to anyone, or whether it's unsafe, or whether it's for internal or even external users available, which can be quite a risk. So if they don't have the right type of data management tools in place with their data lakes, they may not be effective controlling and monitoring data in the data lakes like they should, and to prevent all different kinds of risk. And this is something what we see now in the market, that more and more large vendors are starting to create data management tools that can manage all the multiple data lakes, basically, but also all the different sources on top of a data lake. So at Anand, I think these challenges need to be solved before you can really get value out of a data lake.
which is, you took the words out of my mouth, right? So you talked about how valuable data lakes can be, and you're also telling me here are all the challenges and pitfalls that you can get into. And for someone who's thinking about, okay, should I actually get into this process of building my data lake and start using it? The obvious question is, hey, what do I actually use a data lake for? Where do I see the most value out of a data lake? What are the use cases? Can you walk us through that?
Yeah, so with a lot of potential value. So if you look to data lakes, you have potential to help game business create new insights from all different kinds of data, start combining different data, and create new applications which improve your customer experience. This is, let's say, the high level and the dream for every company and for every data scientist. They also can help customer analytics. Is a main use for data lakes, where you can improve your insights, 360 views. Businesses can help improve customer insights and support the customer experience in all different kind of ways, whether it's insights, whether it's providing data as a service, but also predict and prescribe actions to different systems, or start using it in combination with AI applications, with natural language processing, with speech, with reasoning, with different kinds of AI applications. Customer data can also be combined from all different kinds of sources, so you get a better view. Who is your customer? What is he doing? What is his intent? So businesses can act more quickly and come up with new service models, or even new business models, and improve the customer experience. Data lakes also help to support all kinds of big data initiatives and help companies leverage massive volumes of data in a consistent way and combine this with machine learning algorithms, and you can really apply starting real-time analytics and use your huge amounts of data sets and let's say automating the simple type of repetitive actions with the help of machine learning. It also gives business the potential to collect, to integrate, and to converge all different types of data, no matter what the source or the format is. So they can get more value from all of the data, and basically the fast growing and new data types that are there. You don't need a new system for each new type of data. And it also supports, for example, edge analytics, which means that let's say where the data is collected, you can do analytics. And that's what we see developing quite quickly right now, where you have the central repository, but also have, let's say, the analytics at the device itself, which is called this edge analytics, and where the data is analyzed at the device. So data lake potential capability can help businesses deal with the increasing amount of data. So, Anand, I would say quite some potential which companies have to derive value from the data lake.
So it sounds like, Ronald, when I think about it, there are a lot of ways we can use it, and you have to be very careful about actually managing this data and utilizing it right. So from a business perspective, right, if you want to make sure that you've established a really good end-to-end data management practice, how would that look like? How do they make sure that they're using it to the best of their capabilities and it's done the right way?
Yeah, so we were talking about the development in the market of end-to-end data management solutions. So what we see is that organizations have to govern their data lakes because all these repositories grow, and it becomes really difficult to locate, to trust your data. If there's no trust in data, basically you're lost. If your organization cannot trust it, you don't use the data. It's dispersed, and it's a challenge to utilize data. So the increasing volumes of the data are really surpassing the traditional methods of managing data. So businesses have to look to another way. And this is where end-to-end data management can help. Initially, let's say many companies and the idea in the industry was to have a central repository, but with the growing amount of IoT devices, with the IoT devices generating so much data at the edge, you cannot transport the data anymore. So you need to find other solutions for this part. And on the other hand, we have regulations popping up, which makes it more important to govern and to organize your whole end-to-end data management. And therefore, you need, let's say, technologies that help with collecting, preparing, transforming, and using all of this data. So businesses need to implement an end-to-end data management best practices so that they can prevent from growing the data lakes into an unmanageable, maybe may not say it, but mess of data silos. And this is, I think, the trend for the coming year, where businesses need to focus on this to keep the data manageable. So businesses need a strong data-driven management that focuses on turning this raw data into insights through a really systematic process that's built on automated intelligent technologies. Technologies like machine learning and deep learning can really help in getting the right data, cleaning it automatically, and make it ready for your application. So data management establishes a data lake architecture, and that should be agile and practical for insights and for sharing. So from senior leaders and from management, basically all the way down across different departments and supporting decision making on every level, that's the main purpose for a data lake. So businesses have a few specific areas of data management challenges, like on one end, for example, understanding their dark data that's never used, stored, never used, establishing data accessibility or data retention, and integrating data in a way that it really drives trust analytics. So with an end-to-end data management, businesses will be able to create compliant data and compliant data management processes that really support the data quality, that support the governance, and with the help of machine learning that allows you to locate new data, so you can add metadata to it automatically and make connections between these different type of data sets to get new insights. It also, data management helps you to support data accessibility. It helps you with managing your security. It helps you with securing that information can be shared across all departments and promote really a data-driven culture. Make it accessible, but only accessible for the people that have rights to see it, rights to use it. Which data can you combine? Are you allowed to combine? If you combine two different, let's say, non-personable, identifiable objects, maybe if you combine them, it can be personal identifiable, and you're not allowed to either store this in the GDPR. So through this end-to-end data management, data will be easily and quickly searchable, because it's also, it helps with metadata, meta tagging, so that everybody can find the data that's in either a data lake, but also in the different sources, let's say these 33 sources that we were referring to. It's also important that the data, and especially finding the data that's user-friendly and that's easy access. If it's hard to access the data, which you sometimes now have, a business user cannot find the data. What you see with this data management layer, you can just use it as an advanced search. If you are on Netflix, you search for just one or two keywords, and it gives you an overview from, let's say, the result, but also start advising you which other movies you better can watch based upon your search query and based upon your behavior. And that's also a development now in the market, that you get very advanced searches over all your data in your company, get access to it, define the access to a very detailed level, so you can govern it. So data needs to be properly prepared for all different kinds of further applications, for all the processes, and then it can be used as with advanced analytics techniques such as machine learning, such as deep learning, for deriving value from it. So to prepare the data for advanced analytics techniques, the data needs to be collected from this data lake. it needs to be ingested into the enterprise system, whether it's in batch or whether it's in real time. So the data goes through a preparation cycle with the data management system, from profiling, from combining, from structuring, from cleansing, from enriching, validation, and organize it better, adding metadata to it. And the data preparation enables that the data can be better integrated for better quality, and can be better governed, and it can be easier aggregated in different kinds of purposes. What you also see is that the data can be made available for the data scientist and the analyst, which can easier access the data, set up a notebook, develop a machine learning algorithm, develop some and predict some insights, or start building an application on top of it, just out of this data end-to-end data management solution. So organizations have to build and train machine learning and deep learning models that help them generate these diverse insights, and data management, end-to-end data management solutions help with that. You can build this model, you can use these models, you can start forecasting results, you can start prescribing actions without doing this as a silo approach, just on one database and one solution. So this data management, I think, gives businesses the next step to reach this Valhalla of really using end-to-end your data in your organization. And if you look to machine learning, to deep learning, to analytics, they can help strengthen the role of the management, and in particularly the massive amounts of this raw data, of this unstructured data that's stored in these data lakes. Sometimes a big challenge is, how do you know what you have stored? How can you retrieve it? So machine learning can there help with classification of the data. It can help you with cleansing the data, and can it do in real time, so with streaming data sets or with data at rest, and which help you to further prepare it for all different kinds of applications. Then data scientists can develop algorithms on top of it and build machine learning, and if they go one next level, they can build deep learning models to promote and create all different kinds of applications and show at a higher accuracy, let's say, results, which also increase the confidence and the customer experience. Machine learning can also help organizations to create with data integration with all kinds of methodologies that enable access different sources from where the data is pulled from. And this process can be automated through mapping data sources in the data repository, and minimizing the time it takes for integration and for aggregation. Also, if you look to deep learning, it can help you elevate current analytics application and can help make processes much more efficient. So deep learning's capability to progressively improve and adapt modifications and information in all different kinds of patterns help businesses to apply increased innovation, and I think get a much more robust behavior into their analytics. So once you've trained the machine learning and the deep learning models using this proper framework, it can be deployed and can be maintained for improved performance and can be implemented throughout your data and analytics pipeline. And because you have, let's say, an end-to-end data management system, what you see now often is that groups set up a POC on top of a data lake, but once they move it into production, they have different ETL processes, the algorithms respond differently to this process, the data quality is different, so let's say they fail. With this end-to-end data management solution, you can move it from a POC directly into production, which makes it much more, the chance for success increases substantially. So once machine learning and deep learning models have been deployed, organizations are really better to position to achieve their goals, like predicting outcomes or categorization and classification to add context to data, identifying all different kinds of patterns or detecting anomalies in all kinds of IoT devices and start predicting when a machine will break down, and so you can, let's say, act on it and do some predictive maintenance. It also will support the decision-making capabilities much more. So the models, of course, have to be monitored and analyzed and well managed to evaluate their performance. And that's the new type of challenges which you get, of course, with deep learning, with unsupervised learning. So how can you manage this? And what we see is that this helps businesses, and this end-to-end data management helps businesses to transform their raw data lake material into real, trusted, I would say, business value. And it also helps business to obtain the right data fast, and they can develop the data-driven applications that they need to address the goals. And they meet all various different kinds of, let's say, strategies that you define in your pipeline. So once again, data management, Anand, is an important new type of development which you will see in the market the coming year and will be rolled out across many organizations.
Wonderful. So Ronald, really quick, I think we want to keep a few minutes at the very end to have some questions as well answered. So the next question, let's keep it a little short. I think there's one other aspect of data lakes that is really interesting, right? You talked about GDPR and data security. One thing that comes to mind as I think about data lakes, we can pretty quickly get to interesting places with data lakes, right? So how can effectively managing your data lakes actually establish really strong data security and governance around these? What are some things that you've already seen that work that you can share?
Yeah, so I think an important trend, what we were just discussing, was this data management. Data management is, I think, the foundation to govern your data, to manage it securely, to give, to add metadata, but also define who has access and who has not. So businesses have to be careful to establish data governance and security practices when they manage the data lakes. And I think, yeah, we don't have to explain it. It's really critical. If you don't manage it properly, you get the challenge that we've seen with different kinds of companies with data breaches. So what we see is that recently the GDPR has been implemented in Europe, which has an effect all over the world, because everybody who's working with European citizens has to respect this. So based on this, other countries are reworking their policies as well, because they need to, if they want to work with European people, they have to comply with this as well. And then you need to have this client consent, you need to process the data, and you need to store it, you need to give the right of removal of your personal identifiable data, you have the data portability regulations. So these are all different kinds of aspects where you need to mature your data management, and you cannot just store all your data not knowing what you have stored, because if there's personal identifiable data and you don't have consent, explicit consent from the persons, you are basically breaching the GDPR, giving access to the data and have the possibility, the right to remove it. So you need to know whether you store it or not, otherwise you don't know how to remove it. And the data portability, I think, is one level of additional complexity where you, as an organization, you have to open up your data, and a person can say, I want my data, give it to your competitor. So if you're an iTunes user and you want to go to another streaming music provider, you can say, give all the data that you stored for me, give this to this competitor. So that's, I think, what we see, and where it's really important to have this end-to-end data management in place to govern your data and to keep it secure and to give only access to people that are allowed to use it, but still use your data. Don't have it in a silo, have it available for everybody, basically.
Wonderful, Ronald. So what we'll do now is we'll take a pause. There are a few questions which are to do with education and skills. Those questions myself, since Simplilearn actually is in the area of education and skills. and then we'll come to some questions to you as well, Ronald. So one thing that's coming up here as a question from YouTube, I believe, is, hey, what's a data scientist and what qualifications would you need for a data scientist? Now, while assertively I can't give you a 30-page skill set, one thing that's pretty clear that's coming out as a trend, and by the way, Ronald, me, and another luminary we worked with before, Eric Taylor, we actually discussed this topic at length. And what came pretty clearly out of that discussion was, data scientists tend to be very focused on getting deep insights through an algorithmic approach in providing those capabilities or insights that, a data analyst might not be able to. So a very programmatic approach for doing that, which basically means if you're talking about a data scientist that's going to have a serious impact, number one, you need to understand how to use the data, how to actually, clean it up, and then really make it in a format that you can use it. But separately, you should be able to actually write scripts, programs, to actually extract that data and actually create these kind of models around those. So one of the courses that we actually have on Simplilearn ourselves is we have a course on R and Python. We teach you those kind of courses. So typically, those are the skills that we see in the industry that is highly sought after, and that's pretty common, right?
Yeah, so it's the data preparation, the analysis, the model building, which is important, and the visualization skills. But I think what often is not discussed is the soft skills. It's the communication skills, and understanding the business and having the domain knowledge to transfer the data into value.
Yeah, great point. All right, so one other question that does come up is, Ronald, in terms of data lakes and tools, right? Some of the commonly used tools that are being applied in the market, in the industry today. Anything that you can share on that?
Yeah, so there are a whole set of data lakes, let's say Hadoop providers, whether it's Amazon, whether it's HP, whether it's Google, whether it's Hortonworks, Cloudera, Microsoft Azure, IBM. So there are quite some, let's say, solutions in the market. And on one hand, what we see is that advanced companies now start building the data management applications on top, which, for example, IBM and SAP is doing. But if you, on the other hand, look to, let's say, technologies, it's not a one-size-fits-all. So building a data lake is still quite a challenging task, which requires integration of numerous technologies, different sources, ingestion, processing. So they are not really standard rules and out-of-the-box solution that you just plug in. Also not for your security, not for your governments. It's let's say more complex. So there are many factors that businesses must look into before they select their technology stack. And given these factors, I think you also have to look from a maintenance perspective, a monthly cost perspective, vendor lock-in, scalability, and investment perspective. So yes, there are a numerous number of technical solutions, but start with your business perspective.
And one very related question which has come up as well. If I have an organization, a startup that's just getting started on the data lake story, right? What's my quickest way, or what's my approach? You talked about some of these tools, right? Is there any preferred way that I should get started in this journey in terms of the tools that you just mentioned? Or maybe it's more the fit to form kind of discussion?
Yeah, it's more fit to form. It's not, as I said, it's not a standard plug-in and, you're a startup, so this is your route to go. It really depends. A startup can have huge demands, either from real-time processing requirements, or the other one has much more a whole variety of data, which if you're using with social media, if you're using IoT data. So the requirements from a startup can be sometimes more complex than from, let's say, a traditional organization that exists already for 100 years. So it's not a one-size-fits-all. It's more what's your business, what type of data, what do you need to do with the data, how do you need to process it, what are your hardware requirements, how much money do you have, how big or small can you start. So it's not for startup, then you need to take this solution or need to go this route.
Right. All right, perfect. Thank you, Ronald. And I think, I'll let you glance through the questions really quick while I answer a couple questions as well. So let me take a couple questions and give you a little time to, look at the questions as well. But, one question that's coming up, which, I can tell you with at least, I'm not a data scientist, by the way, but I will answer based on the customers that we get and the trends we see in the market, right? One question that's come up is, if I'm a data scientist, is conventional machine scientist, as we see it, of the folks that come to us, is changing for sure, right? So what's happening is, while the traditional data scientists could use, algorithms through Python or R and just create their own sort of predictive models, what's happening is machine learning algorithms are accelerating the pace at which they can gain insights out of these tools. And so the answer that we're starting to see is that, yes, machine learning algorithms are starting to become a big part of sort of the mainstay of what a data scientist is starting to do. Now, again, that trend has started, and we are seeing that ourselves in the way that data scientists are actually buying our courses, how they're consuming our courses, right? So that is a trend we see. I want to call that out really quick. The other question that is being asked quite a bit is statistics, math, those kind of things. So let me dive a little bit into that in terms of the curriculum that's built based on customer feedback to us. And again, Ronald, if you want to jump in anytime, please do.
Yeah.
We actually have built a curriculum around data science and machine learning, and there is absolutely a refresher on statistics and math. So there is a basic level of math that is required to get pretty strong at being able to implement. Now, do you need all of it to actually implement algorithms? Not necessarily, but understanding what these algorithms can do and knowing those statistical concepts definitely help. But Ronald, if you have any thoughts, feel free to add anything you would like to add there.
Yeah, so I think it's exactly what you say, but I think statistical part is very important, but as well the business understanding and understanding the business and the data from the business. What we see more and more is that you have very specific applications. For example, in the industrial IoT, you have specific anomaly detection for different types of machines, and you really need to understand the data and the business before you can define whether it's an anomaly. So it's a deviation from the normal behavior, but is it a good or a bad anomaly? And therefore, you really need to understand the domain knowledge. And domain knowledge is not something that you can learn from a course. I think it's also some practical experience and diving into the data, start trial and error with the data, and use some experience from, let's say, the people around you that are there for a while, and understand how a machine does behave, and when it when it will be fail, or when it needs to go into maintenance. So I think that's another part next to the courses, just trial and error, and explore the data that you have within your organization.
Wonderful. And I think, we'll take a couple more questions here. One very basic question, which I think you can answer quite well, is, somebody's asked, what is big data? And a related question to that is, if I want to get my first foot into this domain, where should I start, right? So maybe a little bit of a rookie, fresher sort of view of what is big data to them? How do you actually get into this field?
Yeah, so you mean as an implementation or as a person just to start?
Actually, maybe it's a two-part question, because big data and data science
Okay.
are really different things. So whichever one you think is most relevant, I think, the question is actually about both. So first of all, what's big data? How do I get into big data? And then separately, in data science, are there specific things that I can get started with, resources, things like that I can look at?
Yeah, so how to get into big data. Big data, let's say the term was there with the high volume, the high variety, the high veracity, and the speed of collecting of data. And it was hard to handle when the term big data was introduced. What we see now is that the technologies, and especially the GPUs from companies like Intel, are capable in processing large amount of data. So when is it big? I think we are capable of managing basically all types of varieties, all types of veracities, all types of volumes of data nowadays. So I think the big data, it's becoming just data. Then is the question how to get into this field. And I'm a big favor from just start with some courses and combine it with practical applications. So and start with the data that you have within an organization. I see quite some organizations thinking 3 or 4 or 5 steps ahead. We need a data scientist. We need to apply machine learning. But what they forget is the foundation. And the foundation is have your act together with your data collection, have your act together with your data quality, have your act together with your data processing, have your act together with your data governance. Because if you don't have your act together, each step that you're going to take as an organization and start, let's say, do some trial and error and POCs with machine learning applications, gonna fail once you implement them. So I think what we see in the industry, 90% of the companies still have challenges with the foundation. So they work hard on the foundation and they still do some exploration with machine learning and data and let's say all different kinds of sometimes deep learning applications, but that's in a trial and error phase still. So foundation, start with that and then start thinking about predicting, developing algorithms and predicting, let's say, either forecasting, prescribing actions. These are the steps you have to take. So don't start with machine learning, don't start with deep learning before you have your act together.
That is super advice because it's very easy to get carried away by these big terms and names out there.
Yeah, there's a lot of trends and trendy terms, of course. Everybody talks about AI now. Okay, how many companies really develop advanced AI applications that provide a great customer experience? There are a number, either startups or leading companies, and now all the other companies have to, let's say, pick up this new bar that has been set by these companies like Google and Amazon and Facebook from a customer experience perspective. But these companies have a tradition and a foundation and experience from 10 to 20 years of data management. So you cannot say, hey, I'm going to do the same and develop all kinds of new applications with the help of machine learning and AI without this foundation. So start, let's say, crawling before you want to walk and start walking before you want to run. That's more important than still, let's say, this trends and everybody's discussing about it, but who's actually doing it? It's a small group of companies that really are successful in deploying it. So for most of the companies, it's more get your act together.
Wonderful, great advice. So last question for you, Ronald. This discussion was about data lakes, and while we are covering a slightly more broader set of Q&A that's coming from the audience, maybe a parting question for you. You know, in terms of resources on data lakes, if somebody wants to get deeper, you know, there were quite a few questions about how do I get started. So for folks like that, if you want to give some resources that you can point them to, where could they go?
Yeah, I'm a big fan of Twitter on one hand, so you can define all kinds of queries where you find either books, courses, everything, and I'm a big fan of Data Science Central and KD Nuggets, and every day learn a lot from other peers in the industry that share their knowledge, and they do that mainly on these type of sources. But I think as well, educate yourself and get certifications because companies in the end want to have the proof what kind of level you have and what kind of skills and expertise you have, because there's a lot of also, let's say, fake titles or not qualified in using certain titles from, for example, data scientists. So it's better to have your papers and your act together as well from what you can certified by companies like Simplilearn, I think.
I didn't tell Ronald to say that, by the way, folks. That came straight from him.
Straight from the heart, even.
Yes, absolutely. But you know, Ronald, it was a huge pleasure talking to you today about data lakes, getting a bit of insight as to how it's being used, what the challenges are. I learned a lot, I'm sure. So I'm hoping the audience took away quite a few things. And thank you so much for answering some of the questions that came through the Q&A sessions. To the audience, thank you so much for joining us today. We had a blast talking about this topic. And have a great day or good night, wherever you are. Goodbye.
Thank you. Goodbye.